In this video, we're going to learn how to quantify concentration. The unit for concentration in chemistry is molarity. There are other units out there, but we are only going to focus on molarity. That's all you're going to learn for general chemistry. Now, concentration is a measure of how much solid is dissolved in a solution, or how much solute is in the solvent. If you dissolve a little bit of solute, we would say it's a dilute solution. If you dissolve a lot of solute, we say that it's a concentrated solution. So again, like the example I always give is if you're making lemonade, if you mix a lot of powder in with your cup of water, you're going to have a very rich, very sweet lemonade, maybe even too rich, right? It's very concentrated. Now, if you put just a tiny little bit of your lemonade powder into a cup, you're going to have a very weak solution or a very dilute solution of lemonade. So instead of just describing it as a strong or a weak solution, we're going to quantify this using molarity. So molarity is the concentration unit, as I mentioned. It's a capital M. So you've seen that many, many times up to this point. I've said, okay, we're using 3 molar hydrochloric acid today, or you'll see a beaker labeled 6M HCl. That 6M is 6 molar, or the molarity is 6 molar. So it tells you the number of moles of solute per liter of solution, which gives us the equation like this. So molarity is, there we go. Molarity is moles per liter. Yeah, so let's do some calculations with that. So our first problem is, what is the molarity of a 3.5 liter? What is the molarity of 3.5 liters of a solution that contains 90 grams of NaCl? Sorry, I stumbled through that. Kind of rough there. So my equation is moles per liter, but notice that I'm not given moles, I'm given grams, and that's pretty typical because you're going to weigh out your NaCl. You don't weigh out moles, you weigh out grams. So what I'm going to have to do first is I'm going to have to convert from grams to moles. Now to do that, I first have to add up the molar mass. Na, there's one of those. Sodium is 22.99. Chlorine is 35.45. If you add that up, I'm not going to multiply across because I'm just multiplying by 1. So I'm just going to add these up. 1 mole of NaCl weighs 58.44 grams per mole. So now I'm going to take that molar mass and I'm going to use it to convert my grams to moles here. So I take 90 grams NaCl. I bring grams of NaCl down. I'm going to go a little bit quick here because we have been doing these for a while now. The mole gets the 1, and there is 58.44 grams per mole of NaCl. So now I do a little bit of calculations here. 90 divided by 58.44. And that means right now I have 1 point, and I should go to 3 sig figs here. 1.54 moles of NaCl. So now I have my moles to plug in up here. Conveniently, I'm given liters. Typically, you are not. You usually measure in milliliters, so you may have to convert, but not in this case. So my molarity is going to be 1.54 moles of NaCl divided by 3.5 liters of water. So I do that math, divided by 3.5, and I'm going to round to 2 sig figs because I've got 3 sig figs divided by 2 sig figs. And I get 0.44, and then capital M for molarity is my concentration. So if I dissolve 90 grams of sodium chloride into 3.5 liters, my concentration I would write out as 0.44 molar. So that's our first problem. Let's try the next one. This one says, how many moles of HCl are present in 0.8 liters of 0.5 molar of HCl? So again, we're going to use this equation. If you want to give it a shot, you can pause the video and try it on your own. This one's a little bit different. So if you paused, I guess I'll start here. Let's solve this. So this is saying how many moles. So it's asking me to solve for moles, not molarity this time. So it actually gives me the molarity. So I'm going to plug that into there. It gives me a liters. So I'm going to plug this one into here. But before I do that, I'm going to do my rearranging here. To solve for moles, I multiply liters on both sides, multiply by liters, so my liters basically goes that way. So I got liters times molarity equals moles. Now I'm going to plug in my liters, 0.80 liters times 0.50 molarity, which I'm going to actually rewrite that as moles per liter, because remember, capital M is actually moles per liter. So you'll see that my liters cancels out. Now 0.8 times 0.5, I think I can do that in my head. Half of 0.8 is 0.40, and then my units are moles, and it's of HCl. So I know that if I have 0.8 liters, or 800 milliliters, of half a molar HCl, that amount would contain 0.4 moles of HCl. Let's do another example here. How many grams of Cu2SO4 must be dissolved to make 118 milliliters of 1.2 molar solution? Now there's a lot to break down here, so you may want to watch some couple things I want to mention before you try this on your own. First of all, it's asking how many grams. Now grams are nowhere to be found in this equation. So you probably can figure out at this point that you're going to have to solve for moles, kind of like we did in the last problem, and then from there you'll convert it to grams. That's not the only trick you need to know though. This is in milliliters, the volume. So to convert it to liters, you divide by 1,000, move the decimal over to here, and then you can plug it into the bottom. So again, let's go molarity times liters equals moles. So let's quick do that. My molarity is 1.20 moles per liter. Again, I'm using this unit in place of the capital M, just because it's nice to see the units cancel. Then the liters. If you plug 118 into this, you will get the wrong answer. You need to put 0.118 liters. Remember, divide this by 1,000 to convert to liters. Oops, get rid of that. Divide by 1,000. So now if I type this in, 1.2 times 0.118, that equals, and I'm not going to round out yet to sig figs. Well, actually, let's round out here. 0.142, and then that's moles. The reason it's moles is because my liters cancels out. So I know that I have 0.142 moles of Cu2SO4. Now I have to convert that to grams. So let's set up our ladder here. I got 0.142 moles of Cu2SO4. Now I'm going to bring the unit down, moles of Cu2SO4, convert it to grams of Cu2SO4. Let's see here. Bring the 1 down. Now I got to figure out how many grams are in 1 mole, and that's where you do the molar mass. I got 1 of these, 1 of these, and 4 of these. I am going to pause the video here so that you don't have to watch all this. Okay, so it's a good thing I paused on that because that took me like 5 minutes because I made like 3 different mistakes. One of the mistakes was I forgot to multiply this by 2. I forgot that the 2 was there. I think I added up wrong one time. So 1 mole of copper sulfate, copper 1 sulfate has a mass of 223. So that is the number that I put in here, 153. And then I multiply that because it's on top by 0.142. So I multiply across here. My moles cancels out. And I am left with 31.7. I got to round to 3 sig figs. And then that is grams of Cu2SO4. So how many grams must be dissolved? So in order to make this solution, I have to do this math right here, and I know that I will dissolve 31.7 grams of copper sulfate into 118 milliliters, and if I do that, the resulting solution will have a 1.2 molar concentration. So a lot of times in chemistry you're going to have to prepare solutions. This is the calculation you need to make. You typically don't need such an odd number like this, but you might say, okay, I need 50 milliliters of a 0.1 molar solution. How many grams do I have to dissolve? And you'd walk through these calculations and figure out how many grams. You'd weigh that out, and then you'd dissolve it in the volume that you you desire there. And then you have the concentration that you need. Let's see here. Let me check one more thing here. Okay, so this is the last example. Again, it's moles per liter. Pause the video. Try this one on your own. Then I will solve it, and then you can check to see how you did. Okay, so hopefully you're back. So this one is the same thing. How many grams? Same as the last one. Convert this to liters. So I know that that equals 0.250 liters. I know that I need to rearrange this thing to moles times liters molarity times liters equals moles. So then I go 0.250 liters times 0.250 molarity. And 0.25 times 0.25, I should know that, but I don't, so 0.0625. That's how many moles I need. Now I am actually just going to, let's just cheat here a little bit. I'm just going to take that moles, and I have to set up into a ladder to convert my moles to grams. So I'm going to bring moles of NaOH down, and I am going to go to grams of NaOH. Mole gets the 1, NaO and H. I'll pause it here and quick add that up. Okay, so I added up, there's one of each, so I just added up the mass from the periodic table. 1 mole weighs that. So I go 39.99 grams per mole. And because they're both on top, I multiply. These units will cancel, so 0.0625 times 39.99. Sorry, we got a little background noise out in the hall. Let's see here. That gives me to 3 sig figs, 2.499. So I would round that to 2.50 grams of NaOH. So again, if I needed to make 250 milliliters of a 0.25 molar solution, I would need to go weigh 2.5 grams out, dissolve it. So if I had a beaker, let's say it has 250 milliliters. If I want it to have a concentration of 0.25 molar, I would have to weigh out 2.5 grams and dump it into there to have that concentration. Obviously, if I doubled this mass, that would double the moles, that would double my concentration, things like that. So it's a way to quantify how much is dissolved per given volume, right? If I dissolve 2.5 grams into like 10 liters, same amount of moles, but a much bigger liters will give me a much lower concentration, right? Larger volumes are more dilute if you have the same amount of moles. If you have a lot of moles and a little bit of volume, it's very concentrated. A little bit of moles and a lot of volume, not so much. So be able to do these calculations, be able to understand kind of what's happening here. You're measuring how much you're dissolving per given volume. And that's where we'll leave this, and next video we'll talk about dilution problems.